June 23, 1942, Kubinka Airfield, 63 kilometers west of Moscow. Colonel Andrei Georgievich Kuznetsov stood in the early morning mist, his weathered hands gripping a technical report that would change everything Soviet pilots believed about German aviation superiority. The captured Focke-Wulf Fw 190, A-4, registration number 2362, sat on the concrete apron like a predator at rest. Its broad-tracked landing gear and powerful radial engine gave it an appearance of brutal efficiency that made the sleek Soviet fighters nearby look almost delicate by comparison. The numbers on the test report defied belief. Rate of climb at sea level, 17.5 meters per second. Maximum speed at 6,000 meters, 660 kilometers per hour. Roll rate, a complete 360-degree rotation in 2.4 seconds. These figures weren't just impressive, they represented a quantum leap in fighter performance that Soviet intelligence had failed to anticipate. "This cannot be accurate," Kuznetsov muttered to his chief engineer, Major Pavel Ivanovich Fedotov, who stood beside him with his own copy of the report. "Our best pilots reported the Fw 190 was fast. Yes, but this." He tapped the climb rate figures with his finger. "This would make it superior to every fighter we have in service." Fedotov's expression was grim. "Comrade Colonel, I supervised every test personally. We checked the instruments 3 times. We used 3 different pilots to eliminate human error. The results are consistent." He paused, choosing his words carefully. "The Germans have built something we did not think was possible, with a radial engine." The implications were staggering. Since the Fw 190's combat debut over France in September 1941, Soviet intelligence had received scattered reports from the Western Front. The British RAF had initially dismissed these reports as exaggerated. A new German fighter that outperformed the legendary Spitfire seemed impossible. But by early 1942, the mounting evidence was undeniable. Luftwaffe pilots in France were achieving kill ratios that suggested a fundamental shift in aerial combat capability. Now, with a captured example undergoing exhaustive testing at the NIIVVS, the Soviet Air Force Scientific Test Institute, the truth was more disturbing than anyone had imagined. The Fw 190 wasn't just incrementally better than Soviet fighters. It represented a different philosophy of fighter design, one that had produced a machine of devastating effectiveness. The story of how this particular Fw 190 fell into Soviet hands reads like a thriller, though the details would remain classified for decades. On April 4, 1942, Oberleutnant Heinrich Schwarz of Jagdgeschwader 54 had taken off from an airfield near Rzhev for what should have been a routine escort mission. His Fw 190A4, freshly delivered from the factory just 6 weeks earlier, represented the latest production standard with improved armor protection and the BMW 801D2 engine. What happened next remained unclear even after extensive interrogation of Schwarz himself. Some reports suggested engine trouble, a coolant leak that had gone unnoticed during pre-flight inspection. Others claimed Schwarz had become disoriented during a low-altitude pursuit and found himself behind Soviet lines with insufficient fuel to return. The official Luftwaffe report, discovered in archives after the war, simply stated, "Aircraft 2362 failed to return from mission. Pilot status unknown." What is certain is that Schwarz made a wheels-up landing in a field approximately 40 kilometers behind Soviet lines. Local partisan units reached the crash site within hours, finding the pilot injured but alive and the aircraft surprisingly intact. The Fw 190 had plowed through soft spring mud that cushioned the impact. leaving the fuselage structurally sound despite damage to the propeller and lower cowling. Within 24 hours, a recovery team from the 3rd Air Army had transported the aircraft to a forward repair facility. Within a week, Soviet engineers were examining every rivet, every control surface, every technical detail of Germany's most advanced fighter. The discovery was electric. This wasn't a battle-worn machine cobbled together from salvaged parts, but a nearly new production aircraft with less than 40 flight hours on its airframe. Colonel General Alexander Novikov, commander of the Soviet Air Force, personally ordered the aircraft's immediate transfer to NYVVS at Kubinka. "I want to know everything about this machine," he reportedly told his staff. "How it flies, how it fights, and most importantly, how we beat it." The initial technical examination of the FW-190 revealed design decisions that challenged fundamental Soviet assumptions about fighter aircraft development. For decades, Soviet aeronautical engineers had been trained in a design philosophy that emphasized lightweight construction, minimal frontal area, and inline liquid-cooled engines for reduced drag. The Yakovlev, Lavochkin, and MiG design bureaus had all followed these principles, producing fighters that were nimble, fast climbing, and relatively easy to manufacture. The Focke-Wulf Fw 190 violated nearly every one of these principles, and somehow achieved superior performance anyway. Chief Engineer Fedotov's preliminary report, dated April 15, 1942, captured the team's bewilderment. The aircraft presents a paradox in aerodynamic design. The use of a large-diameter radial engine creates significant frontal drag that should, by conventional analysis, reduce maximum speed by at least 40 to 50 kilometers per hour compared to inline engine designs of similar power. Yet flight testing demonstrates the opposite. We must conclude that German engineers have made advances in detail design and systems integration that compensate for fundamental aerodynamic disadvantages. The BMW 801D2 engine particularly impressed Soviet engineers. This 14-cylinder, 2-row radial produced 1,700 horsepower on takeoff and maintained 1,440 horsepower at 5,700 meters altitude using the MW50 methanol water injection system. More impressively, the engine featured an automatic control system, the commando gyrate, that managed mixture, timing, boost pressure, and propeller pitch through a single throttle lever. Soviet test pilot Major Mikhail Alekseyev, a veteran with over 800 combat hours who would later conduct the official flight tests, examined the cockpit with visible amazement. "In our fighters, the pilot must constantly monitor and adjust multiple engine parameters," he explained to the engineering team. "Mixture control, propeller pitch, supercharger settings. Each requires continuous attention, especially during combat. This system does it automatically. The pilot simply advances the throttle, and the engine delivers optimal power for the current altitude and airspeed." The implications for combat effectiveness were profound. Soviet fighters required skilled pilots who could manage complex engine operations while simultaneously fighting. The FW-190's automated systems reduced pilot workload dramatically, allowing even less experienced pilots to focus entirely on tactics and gunnery. The aircraft's structural design revealed equally sophisticated engineering. Unlike Soviet fighters that used primarily wooden construction for wings and fuselage components, the FW-190 was almost entirely metal. The fuselage was a semi-monocoque structure of aluminum alloy formers and stringers covered with stressed aluminum skin. This construction was heavier than Soviet mixed construction techniques, but provided superior strength and durability. Most remarkably, The entire engine installation was designed as a quick-change unit. The massive cowling, engine mount, and accessories could be removed as a complete assembly in less than 30 minutes, using standardized attachment points. Soviet mechanics, accustomed to engines that required hours or even days to remove and replace, could scarcely believe the demonstration when German POW mechanics were brought in to show the procedure. "This is not just an aircraft," Fedotov wrote in a classified addendum to his report. "This is an industrial product designed for mass production and field maintenance under combat conditions. The Germans have integrated manufacturing considerations into every aspect of the design. We have much to learn." On May 8, 1942, Major Alekseyev climbed into the cockpit of the Fw-190 for the first time. Soviet engineers had spent 3 weeks repairing the landing damage and verifying all systems. The aircraft had been repainted in Soviet markings with prominent red stars to prevent friendly fire, though the distinctive silhouette would still draw suspicious looks from Soviet anti-aircraft gunners. Alekseyev's preliminary flight report, written in the precise technical language required by NIIVVS protocols, barely concealed his amazement. Initial engine start revealed exceptional refinement. The BMW 801 runs smoothly at idle, with minimal vibration transmitted to the airframe. Taxiing characteristics are excellent. The wide-track landing gear provides superior stability compared to Soviet types. Forward visibility while taxiing is adequate despite the large engine, better than expected. Takeoff acceleration is impressive. The aircraft reaches flying speed quickly with minimal tendency to swing. Elevator authority at low speeds is excellent. The aircraft breaks ground cleanly and climbs away at a steep angle with full military power. Initial climb performance exceeds specifications of all Soviet fighter types by significant margin. Rate of climb at sea level is measured at 17.5 meters per second, approximately 30% better than Yak-1 and 40% better than Lee GG-3 under similar conditions. The aircraft reaches 5,000 meters altitude in 5 minutes 48 seconds from brake release. But it was Alekseyev's assessment of the Fw-190's handling that truly alarmed Soviet aviation authorities. Roll rate is exceptional, far superior to any Soviet or Allied type. The aircraft can execute a complete 360-degree roll in approximately 2.4 seconds. This provides enormous tactical advantage in combat. The Fw-190 can reverse turn direction faster than an opponent can track the movement. Combined with excellent high-speed handling, this makes the aircraft extremely difficult to follow in high-speed combat. Control harmony is excellent at all speeds. The aircraft transitions smoothly from low-speed climb to high-speed dive with no tendency to tighten up or become oversensitive. Stick forces are well balanced and provide good feedback. Recovery from high-speed dives is straightforward with no tendency to compress or lock. High-speed stability is remarkable. I achieved 700 kilometers per hour indicated airspeed in a 30-degree dive from 6,000 meters. The aircraft remained controllable with no buffeting or tendency to diverge. Our fighters experienced severe control problems at these speeds. The Fw-190 feels solid and responsive. The test reports from May through July 1942 painted a comprehensive picture of German technical superiority that deeply concerned Soviet military leadership. Comparative flights against the Yak-1, Yak-7, La GG-3, and MiG-3, the frontline Soviet fighters of 1942, demonstrated the Fw 190's advantages in nearly every performance category. Against the Yak-1, considered the best Soviet fighter then in production, the Fw 190 was 50 to 60 kilometers per hour, faster at all altitudes, climbed significantly better, and possessed devastating roll rate advantage. Only in turning radius at slow speeds did the lighter Yak-1 show superiority, and even this advantage could be negated by the German pilot using vertical maneuvers and superior energy retention. The LGG-3, plagued by being underpowered and heavy, was completely outclassed. Test pilot Lieutenant Colonel Andrei Kubishkin, who flew comparative trials in June, reported, "The LGG-3 has no advantage over the Fw 190 in any flight regime. In combat against this aircraft, LGG-3 pilots must rely entirely on enemy pilot error or tactical surprise. In any sustained engagement, the outcome is predetermined. Even the MiG-3, designed as a high-altitude interceptor, with excellent performance above 6,000 meters, proved inferior to the Fw 190 in most respects. The German fighter maintained its performance advantages even at altitudes where the MiG-3 was supposedly optimized." As testing progressed through the summer of 1942, Soviet military analysts began compiling reports on the tactical implications of the Fw 190's capabilities. These classified assessments, many of which remained secret until the 1990s, revealed deep concern about the growing qualitative gap between German and Soviet fighters. Major General Georgy Baidukov, a renowned test pilot and hero of the Soviet Union, submitted a particularly blunt assessment in July 1942. The appearance of the Fw 190 in significant numbers on the Eastern Front will create severe problems for our fighter aviation. Our current tactics, which rely on numerical superiority and the ability to sustain turning engagements, will be ineffective against an opponent who can dictate engagement terms through superior speed and climb performance. The Fw 190 pilot can choose when to fight and when to disengage. Our pilots cannot force combat on an unwilling opponent. This fundamentally changes the tactical situation. We must develop new tactics that account for our fighters' inferior performance, or we must produce new aircraft that can compete on equal terms. Baidukov's report included specific tactical recommendations that would influence Soviet fighter doctrine for the remainder of the war. Avoid high-speed combat. Soviet fighters should not attempt to engage Fw 190s in high-speed slashing attacks or dive and zoom tactics, where the German aircraft's superior roll rate and high-speed handling provided overwhelming advantages. Force low-speed, turning fights. Soviet fighters should attempt to reduce engagement speeds where their superior instantaneous turn rate could be employed. This required disciplined formations and willingness to absorb initial attacks while maneuvering into favorable positions. Use numerical superiority aggressively. Solo Soviet fighters or small formations should avoid combat with Fw 190s when possible. Large formations with numerical advantage could overwhelm German fighters through cross-cover tactics and multiple simultaneous threats. Exploit tactical initiative at low altitudes. Below 3,000 meters, the performance gap narrowed somewhat. Soviet fighters operating at low altitudes could partially offset the Fw 190's advantages through aggressive use of terrain and superior knowledge of local geography. Maintain energy in combat. Soviet pilots must preserve speed and altitude advantage religiously. An Fw-190 that gained energy advantage over a Soviet fighter could almost never be caught or evaded by a slower opponent. These tactical recommendations were distributed to frontline units in late 1942, though many pilots initially resisted the implications. The Soviet fighter pilot culture emphasized aggressive offensive action and individual initiative. The idea of avoiding combat or fighting defensively against German fighters challenged fundamental assumptions about Soviet aerial combat doctrine. As Soviet understanding of the Fw-190's capabilities grew through testing, uncomfortable questions arose about how German aviation had achieved such a dramatic leap forward without Soviet intelligence detecting it. The failure represented a significant breakdown in technical intelligence gathering that had implications far beyond a single aircraft type. The Fw-190's development history, pieced together from German documents after the war, revealed that the aircraft had been under development since 1937. Kurt Tank, technical director of Focke-Wulf Fw, had begun preliminary design work on the project even before the war started, driven by his belief that radial engines offered advantages in reliability, battle damage tolerance, and ease of maintenance that outweighed their aerodynamic disadvantages. Soviet intelligence had known about the Fw-190's existence since 1940, when reports from agents in Germany mentioned a new fighter under development to supplement the Bf-109. But these reports had consistently underestimated the aircraft's performance potential, assuming that a radial engine fighter would be inferior to inline engine designs. Major General Ivan Tulenev, chief of Soviet Air Force intelligence, later wrote in his unpublished memoirs about the intelligence failure. "We knew the Germans were developing the Fw-190. We had reports from multiple sources. What we failed to grasp was the sophistication of German aeronautical engineering. We assumed, based on our own experience with radial engine fighters, that the Fw-190 would be inferior to the Bf-109 in performance. This assumption was fundamentally wrong. Our intelligence apparatus was structured to count aircraft, identify units, and track deployments. We were less effective at assessing technological advances and their tactical implications. The Fw-190 represented a technological surprise because we didn't believe such performance was possible from the basic design concept." The intelligence failure had operational consequences. When Fw-190s began appearing over the Eastern Front in limited numbers in late 1941, Soviet commanders initially dismissed pilot reports of superior German fighter performance as exaggeration or excuse-making. Losses were attributed to pilot error or tactical mistakes rather than genuine equipment disadvantage. Only when the captured aircraft proved the pilot reports accurate did Soviet military leadership acknowledge the problem's scope. By mid-1942, Fw-190s were being produced at a rate of over 200 aircraft per month, and Luftwaffe units on the Eastern Front were beginning to re-equip with the new type. As knowledge of the Fw-190's capabilities spread through the Soviet Air Force in late 1942, frontline pilots had to confront uncomfortable truths about their equipment's limitations. The psychological impact was significant. Soviet pilots had been told repeatedly that Soviet aviation technology was superior to German designs, part of the broader propaganda narrative about Soviet industrial and technical prowess. Captain Ivan Kozhedub, who would become the highest-scoring Soviet ace with 64 confirmed victories, encountered the Fw-190 for the first time in March 1943. His account, recorded in his 1985 memoir, captures the shock of facing the German fighter. We were patrolling at 4,000 meters when I saw them, 4 Fw-19s approaching from the sun. I called the warning and began a climbing turn to gain position. That was my first mistake. The German formation leader simply pulled up his nose and climbed away from us effortlessly. We were in Yak-1s, climbing as hard as our engines would allow, and the Fw-19s pulled away as if we were standing still. The leader reversed his climb into a diving turn and came down on my wingman like a falling stone. I tried to intercept, diving and turning to cut him off. That was my second mistake. The Fw-190 rolled upright so quickly I thought I was seeing double. One moment he was inverted in a split S, the next he was level and climbing away again. We never got a decent shot that entire engagement. They made one more high-speed pass, damaged one of our aircraft, and departed to the west, climbing away at a speed we couldn't match. It was a humbling experience. These weren't superior pilots. They were average pilots in superior machines. Kozhedub's experience was typical of Soviet pilots encountering the Fw-190 for the first time. The tactical recommendations from NIIVVS helped, but could not eliminate the fundamental performance disadvantage. Soviet pilots had to rely on discipline, numerical superiority, and tactical patience. Virtues that did not come naturally to young fighter pilots eager to prove themselves in combat. The psychological toll of flying inferior equipment should not be underestimated. Soviet pilots knew before every mission that they would be outperformed by German fighters in any sustained engagement. They knew that survival often depended on enemy mistakes or tactical circumstances, rather than their own skill and equipment. This knowledge created tremendous stress that affected morale and combat effectiveness. Senior Soviet aces learned to exploit the Fw-190's few vulnerabilities. The German fighter's turning radius at low speeds was inferior to most Soviet types. Its visibility downward and to the rear was limited by the large radial engine and cockpit structure. The aircraft was heavier than Soviet fighters, giving it poorer instantaneous turn performance, even if sustained turn rate was similar. Captain Alexander Pokrishkin, the second highest scoring Soviet ace with 59 victories, developed tactics specifically for combating the Fw-190. You cannot fight the Fw-190 with speed and altitude. They win that game every time. You must fight them with angles and position, stay low, forcing them to dive to attack. When they dive, brake hard into the attack, making them overshoot. They are fast but heavy. They cannot reverse direction quickly at low altitude. Work in pairs, always. One pilot acts as bait, staying slightly higher, drawing the German into a diving attack. The second pilot waits below and behind, positioned to attack when the German commits to the diving pass. The Germans cannot see the low aircraft until they are in the attack run. If the timing is correct, you can achieve a firing position before they can disengage. Most importantly, be patient. The Fw-190 pilot will eventually make a mistake, turn when he should run when he should turn, misjudge his energy state. When he makes that mistake, you must be in position to exploit it instantly. You may not get a second chance. These tactics worked, but they required exceptional discipline and teamwork. They also required accepting that Soviet fighters would operate at a tactical disadvantage throughout the engagement, waiting for opportunities rather than creating them through aggressive action. The captured Fw-190 at Kubinka became one of the most intensively studied aircraft in Soviet aviation history. Engineers from every major design bureau visited the facility to examine the German fighter and learn from its design solutions. The aircraft flew hundreds of test flights, was disassembled and reassembled multiple times, and served as a benchmark for new Soviet fighter development. Alexander Yakovlev, designer of the Yak series fighters, spent 3 days at Kubinka in June 1942 studying the Fw-190. His subsequent report to Stalin revealed how profoundly the German aircraft had influenced his thinking. The Fw-190 demonstrates that our approach to fighter design requires fundamental revision. We have prioritized lightweight and simplicity, assuming these characteristics would produce superior performance. The Germans have shown that sophisticated systems, integration, and detail engineering can overcome apparent aerodynamic disadvantages. The Fw-190's automatic engine control system alone provides enormous tactical advantage. Our pilots must divide attention between engine management and combat tactics. German pilots can focus entirely on fighting while their aircraft manages itself. This is a force multiplier that equals several hundred additional aircraft. I recommend immediate development of similar systems for Soviet fighters. We must also study the Fw-190's structural design, its high-speed aerodynamics, and its systems integration. Simply copying specific features will not suffice. We must understand the underlying design philosophy and adapt it to Soviet production capabilities. The Yak-3, which entered service in 1944, incorporated many lessons learned from the Fw-190 study. Though lighter and powered by a liquid-cooled engine, the Yak-3 featured improved high-speed handling, better roll rate, and reduced control forces that reflected German design influence. The aircraft proved highly effective in combat, with Soviet pilots finally possessing a fighter that could engage the Fw-190 on more equal terms. Semyon Lavochkin, whose LeGG-3 had been devastated in comparative testing against the Fw-190, undertook a complete redesign of his fighter line. The Le-5, powered by an air-cooled radial engine like the German fighter, entered service in late 1942. While not quite matching the Fw-190's performance, the Le-5 significantly narrowed the gap and provided Soviet pilots with a competitive aircraft for the first time. The Le-5FN variant, introduced in 1943 with direct fuel injection and improved supercharging, came closest to matching the Fw-190's capabilities. Soviet ace Vitaly Popkov, flying the Le-5FN, shot down 12 Fw-190s and later commented, "With the Le-5FN, I could finally fight the Germans on equal terms. Not superior terms, but equal. That was enough." As Soviet fighters improved through 1943 and 1944, the Luftwaffe continued developing the Fw-190. Later variants, the A5, A6, A8, and the high-altitude D9 model, maintained Germany's qualitative edge, though the performance gap gradually narrowed as Soviet aircraft improved. The Fw-190D9, introduced in late 1944 with an inline Jumo 213 engine, represented the ultimate development of the basic design. Soviet test pilot Mark Galay, who flew a captured D9 in early 1945, was stunned by its performance. This aircraft is in a different category from anything we have encountered. Maximum speed of 685 kilometers per hour at 6,600 meters, rate of climb exceeding 20 meters per second, exceptional handling at all speeds. If the Germans had produced this aircraft in 1943 instead of 1944, the air war would have been drastically different. Fortunately for us, it appeared too late and in too few numbers to affect the war's outcome. But flying it was a revelation. German aeronautical engineering had not stagnated despite their desperate strategic situation. They continued to produce technical innovations even as their industrial base was being destroyed. By 1945, the technological race had become largely irrelevant to the war's outcome. Germany lacked the fuel, trained pilots, and industrial capacity to exploit its technical advantages. Soviet numerical superiority, combined with gradually improving aircraft quality, overwhelmed the Luftwaffe through attrition rather than technical superiority. But the lessons learned from the captured Fw-190 at Kubinka continued to influence Soviet aviation development long after the war ended. The aircraft had demonstrated that Soviet design philosophy, while producing adequate fighters quickly and in large numbers, had sacrificed performance and sophistication that could have saved thousands of Soviet pilots' lives. Statistics can quantify performance differences, but they cannot capture the human cost of flying inferior equipment in combat. Soviet fighter pilots from 1942 through 1944 faced German opponents who possessed significant technical advantages. The psychological and physical toll of this disadvantage shaped a generation of Soviet aviators. Lieutenant Alexei Maresyev, whose story became legendary in the Soviet Union, survived being shot down by an Fw-190 in April 1942. His testimony about the engagement reveals the helplessness Soviet pilots felt when confronted by superior German fighters. "I was flying a Yak-1, escorting Sturmovik's attacking German positions. We saw them coming, 4 Fw-190s, diving from above and behind. I broke hard left, trying to turn inside the leader's attack. It was useless. He simply rolled level, pulled up, and reversed back into me from another angle. I couldn't follow the maneuver. My aircraft wouldn't respond that quickly. The second pass hit my engine. I saw flashes along my wing route, felt the aircraft shudder, then smoke began pouring into the cockpit. I dove away, trying to reach Soviet lines, but the Fw-190 followed easily, hitting me twice more. I crashed in no man's land and crawled for 18 days to reach Soviet positions. Both my legs were badly injured. They were later amputated. I survived because the German pilot chose to leave after the third pass. If he had stayed, I would have died in the air. I was not shot down by a superior pilot. I was shot down by a superior machine, flown by an average pilot who made no mistakes because his aircraft forgave his mistakes." Maresyev's story had a remarkable epilogue. He returned to combat flying in 1943 with prosthetic legs, eventually shooting down 7 more German aircraft. But his testimony about the hopelessness of fighting the Fw-190 in an inferior aircraft was echoed by thousands of other Soviet pilots. The casualty statistics tell a grim story. Soviet fighter pilot losses increased dramatically in sectors where Fw-190s operated. Analysis of combat reports from 1942 to 1943 showed that Soviet fighters engaging Fw-190s suffered loss rates 40 to 60% higher than when engaging Bf-109s, which themselves were excellent aircraft. Junior pilots faced the worst odds. Experienced Soviet aces could exploit the Fw-190's few weaknesses and survive through superior tactics and situational awareness. New pilots, still learning basic combat skills, were devastated. The average life expectancy of a replacement Soviet fighter pilot in units facing Fw-190-equipped Yugoslavia was measured in weeks, not months. Colonel Nikolai Yakubov, commander of the 151st Fighter Regiment, wrote in his after-action report from August 1942, "We have received 14 replacement pilots since June 1st. Of these, 11 are dead or missing, 1 is severely wounded, and 2 remain in the regiment. None achieved a confirmed victory before being lost. The survivors are not the best pilots. They are the luckiest. Against the Fw-190, luck matters more than skill for inexperienced pilots." I have recommended to Army Command that new pilots receive at least 50 additional flight hours before assignment to frontline units facing 190 equipped German formations. This recommendation has been rejected due to pilot shortages. We will continue to receive inadequately trained replacements who will continue to die without significantly affecting the enemy. The human cost of technical inferiority extended beyond combat casualties. Soviet fighter pilots suffered from chronic stress related to flying inferior equipment. Medical reports from 1942 to 1943 documented increased rates of combat fatigue, stress-related illness, and psychological problems among pilots in units facing technically superior German fighters. Some pilots requested transfers to Sturmovik ground attack units, reasoning that facing ground fire in an armored aircraft was preferable to facing Fw-190S in an outmatched fighter. Others developed various coping mechanisms, superstitions, ritualized pre-flight procedures, or psychological compartmentalization that allowed them to function despite knowing their aircraft's limitations. While Soviet pilots struggled against the Fw-190 in combat, Soviet propaganda worked to minimize public awareness of German technical superiority. Newspaper articles and newsreels emphasized Soviet numerical superiority and pilot bravery while downplaying equipment deficiencies. The captured Fw-190 at Kubinka became a propaganda opportunity. Carefully staged photographs showed Soviet pilots standing beside the German fighter, with captions emphasizing that German technical achievements could be studied and countered. What the photographs didn't show was the extensive testing that revealed just how superior the German aircraft actually was. Ilya Ehrenberg, one of the Soviet Union's most prominent war correspondents, wrote in Pravda in September 1942. Our pilots have examined the vaunted German Focke-Wulf fighter. Yes, it is a formidable machine, built with typical German technical proficiency. But it is just a machine, metal, rubber, and fuel. It can be shot down like any other aircraft. Our pilots have already destroyed dozens of these fighters in combat. German technology cannot overcome Soviet courage and determination. Ehrenberg's article was factually accurate. Soviet pilots had indeed shot down many Fw-190s by September 1942. What it omitted was the casualty exchange rate, which heavily favored the Germans, and the tactical constraints Soviet pilots faced when engaging the technically superior fighter. This propaganda served necessary purposes. Soviet morale required maintaining public confidence in Soviet military capability. Revealing the full extent of German technical superiority might have undermined public support for the war effort. Soviet pilots themselves needed to believe they could win despite equipment disadvantages. Defeatism would have been militarily catastrophic, but the propaganda created tension with frontline reality. Pilots who survived encounters with Fw-190s knew the truth about German technical superiority. They read newspaper articles praising Soviet aviation and felt betrayed by the disconnect between official narrative and combat reality. Senior officers walked a difficult line between maintaining morale and preparing pilots for the reality they would face. Some commanders distributed classified tactical bulletins that frankly acknowledged German technical advantages while emphasizing tactics for survival and victory. These bulletins were often more valuable to pilots than official propaganda that denied or minimized the problem. The Fw-190's performance shocked not only Soviet pilots, but also British and American aviators who encountered it. The RAF had experienced similar trauma when Fw-190s appeared over France in 1941, devastating Spitfire squadrons that had considered themselves invincible after winning the Battle of Britain. British intelligence shared some information about the Fw-190 with Soviet counterparts through the military mission in Moscow. However, full technical data was not provided, partly due to classification concerns and partly due to Western reluctance to reveal the extent of their own technical intelligence gathering. When the Soviets captured their intact Fw-190 in April 1942, they possessed the most complete example of the aircraft available to the Allies at that time. The British had recovered, crashed Fw-19s, but none were as complete or as well preserved as the Soviet capture. Air Vice Marshal Roderick Hill, who visited the Soviet Union in July 1942 as part of a technical liaison mission, was allowed to examine the captured Fw-190 at Kubinka. His report to the Air Ministry provides an interesting perspective on Soviet reactions. The Russians are clearly impressed by the Fw-190's performance and concerned about its implications for their fighter force. Their testing has been thorough and professional, in some respects more comprehensive than our own evaluation of crashed examples. What struck me most was the Soviet engineers' focus on understanding not just what the Fw-190 can do, but how German industry achieved these capabilities. They are particularly interested in manufacturing techniques, systems integration, and quality control. They see the Fw-190 not just as a combat aircraft, but as an example of industrial sophistication they must match. The Russians are at a disadvantage compared to our position. While we are gradually receiving improved Spitfire variants that can compete with the Fw-190, Soviet fighters lag significantly behind. They are working urgently to close the gap, but realistically, they face another 12 to 18 months of technical inferiority. Hill's assessment proved accurate. Soviet fighters gradually improved through 1943 and 1944, narrowing but never completely closing the performance gap with German fighters. The Fw-190 continued to evolve as well, maintaining German technical advantage until the war's end, though decreasing German industrial capacity meant fewer aircraft were available to exploit this advantage. The Soviet test pilots who flew the captured Fw-190 extensively provided some of the most detailed technical assessments. These men were among the most experienced and capable pilots in the Soviet Union, with thousands of flight hours in dozens of different aircraft types. Their evaluations carried special weight because they could compare the Fw-190's characteristics against virtually every other fighter in the world. Hero of the Soviet Union. Stepan Suprun, one of the primary test pilots for the Fw-190 program, provided a comprehensive assessment in his August 1942 report. The Focke-Wulf Fw-190 represents the most complete fighter aircraft I have flown. By complete, I mean the integration of engine, airframe, systems, and armament into a coherent package optimized for combat effectiveness. Engine management. The BMW 801 with its automatic control system is revolutionary. The pilot advances the throttle, and the engine delivers optimal power for all conditions. Mixture, propeller pitch, boost pressure, and ignition timing are managed automatically. In combat, this eliminates an enormous source of workload and potential error. Soviet pilots must constantly monitor and adjust multiple engine parameters. German pilots can focus entirely on fighting